Hey everybody, this is Gregory from DApp University. So in this video, we're talking about how to write Ethereum smart contracts with the Solidity programming language for the blockchain. And we're talking about how to write functions in Solidity and how to work with events and some new changes in Solidity version 0.5 and a whole lot more. So let's go ahead and jump into this. But before we do that, be sure to subscribe to this channel if you haven't already and click the like button down below. That really helps these videos get found so that more people can learn how to build blockchain technology. Let's use the same My Contract example that we've been using throughout this tutorial series. And you don't necessarily have to have been following along with every video in this series. You can kind of just pick back up with this one probably. So yeah, let's go ahead and jump in and start programming. What I'm going to show you first is how to write a function that accepts Ether. So basically, like, how can we send Ether in when we call a function and do stuff with it? So I'll show you how to do that. First, we'll create a function called buy_token. Say buy_token. And this function is going to kind of emulate what happens in an ICO, like a crowd sale or a pre-sale or something like that on Ethereum, where you're buying ERC20 tokens. I'm not going to code out an entire ERC20 token smart contract right here, or code out a crowd sale smart contract. I've got several other tutorials that show you how to code your own cryptocurrency on Ethereum with build an ERC20 token step by step and a real world crowd sale and things like that. So you can check out those other videos if you're interested. But what we're going to do is basically create this function called buy_token. It's going to simulate what happens. It's not going to do everything, but it'll at least give you an idea of how that works. So we'll call this buy_token. And inside here, what we basically want to do is buy a token. And we also want to send Ether to the wallet. So what's going to happen is someone's going to call this function, and they're going to send Ether when they call this function. And when they do, we're going to issue them a token. And then the wallet is actually going to receive the Ether that they sent in when they call this function. So I'll show you how to do that. First, I'm going to create a way to track the tokens. And basically all this is going to do is track this person's balance. So we'll use a mapping for that. We'll say mapping. And again, if you didn't check out the other videos, the mapping is like an associative array where we have key value pairs. So we'll say address will be the key and the value will be an unsigned integer. All right, and this will be public. All right, this will give us a function for free that will allow us to read this value, and we'll just call this balances. So what we'll do, and when we buy a token, we'll basically just say balances of whoever called this function. So if you'll remember from the last videos in this series, we get that value with msg.sender. This is the account that's calling this function. And we will just increment this count by 1. Now this is not really fancy. We're basically just saying whenever you call this function, you're going to buy 1 token. We're not using a rate of redemption or anything like that. This is just to kind of show you how this works. This is not very sophisticated. But basically that'll just increment your balance, inside this token contract by 1. And whenever we do that, we want to transfer funds that are sent in with this smart contract to a wallet. All right. So how do we do that? Well, first we keep track of a wallet. We'll just declare a state variable here. We'll say address wallet. And we want to send funds to this wallet. Okay. And we do that like this. And I'm actually going to show you something in a minute that's going to be a Solidity 0.5 update. So if you've been using previous versions of Solidity, we have to make a change here. I'll go back to that in a minute. But anyways, let's transfer funds to this wallet. We'll do that like this. So we'll say wallet transfer. And we want to transfer in the funds that are sent by this function. Transfer the funds that are sent in by this function to this wallet. So how do we do that? Well, how do we actually know what the value is that's getting sent in? Well, just like msg.sender, msg has another property called value. So it can say msg.value. All right. And that's going to tell us exactly how much Ether or Way is sent in by the person who's sending this function. So I'll show you how that works. So what that's going to do is take the ether that's sent in with this function call and transfer it to this wallet right here. Now this is not complete. There's a lot of things that actually need to change in order for this to work properly. You can see these X's over here, these compiler errors. So the first thing we need to do is set a wallet. Let's do that inside a constructor. We'll do that whenever we deploy the smart contract. So we'll say constructor. We'll say address, wallet. We'll say public. And we'll say wallet is just equal to the wallet we pass in. All right, so we're still getting errors. Now let's see what they are. The first thing we need to do in order to make this function accept Ether, well, actually, first we need to make it public so that people can call it. We say public. All right. So now people will actually be able to call this function and send Ether in and stuff like that. And in order for this to accept Ether, we have to add another modifier here, which is payable. All right. And if we don't do that, this won't allow us to send Ether in with the transaction. So this is how we declare that this function will accept Ether, okay? Now here's a new Solidity update. It requires explicitness whenever you're declaring an address that can accept Ether inside of a smart contract. And we do that like this. We say address payable wallet, all right? And then likewise, we say address payable wallet whenever we pass this function into the constructor. All right, so that should be a working implementation of what we want to see. So let's deploy the smart contract and try it out. I will take one of these addresses, and we'll take the second address here in the list, and we'll use that as the wallet. We'll actually check its balance here in a second. So we'll deploy the smart contract. We need to pass in a wallet whenever we deploy. Just paste this in, click deploy. All right, looks like it was successful. Let's try to do the buy token function, okay? It's just going to buy one token for us. So we'll make sure we've got the first account in the list selected. We'll buy token. All right, looks like it was successful. Let's check the balance of this. Oops, I actually pasted in the wrong address. Pasted in the second address. So let's try the balance again. All right, it's 1. All right, now all that did was actually transfer, all that did was buy a token. It didn't actually transfer Ether to the wallet, and that's what we want to show. So in order to send Ether in and actually transfer funds to the wallet, we would do that like this. We'd change this to Ether. I'm going to send 1 Ether in with this transaction whenever we call the buy tokens function. We'll do that from this account, and we'll click buy token. All right, boom. So let's check the balance again. All right, the balance is 2. Now, let's see what happened. We can see that the Ether value decreased here from 99.9 to 98.9. It actually took Ether out of our wallet because we sent it in with the transaction. And we can see that this second account on the list, which I used as the wallet whenever we deployed, has been credited with that Ether. So our smart contract worked. It actually sent, the value that we sent in with this to that account. All right, so the next thing I want to show you is how you can create basically a fallback function in Solidity. I guess is what it's called. At least that's what I've seen it called. I'm not sure what the official name is. But basically, it's going to be like a default function that you can wrap this in so that whenever you just send Ether to the smart contract, it executes a function. And you'll see that a lot in ICOs where they have an address posted and they say, hey, send Ether to that smart contract, and it'll actually buy the tokens for you. Now, this is just a kind of pseudocode implementation, again, of a purchase function. A real ICO functionality would be much more complex than this, but you get the idea. So to do this fallback function, we'll do like this. We'll just say function, all right, and we'll say external payable, and we'll just wrap this with the buy token function. All right. So here's a new modifier I don't think we've used yet, which is external. So that's different from public because public can be called, inside of our smart contract as well as outside, but external can only be called outside. So we don't want to call this, inside the smart contract somehow. So now if we just compile this again and deploy, I'm going to paste the wallet in here, deploy. We'll see you have a new function just called fallback. And we can basically just do that like this. So we'll just send one ether from account number 1, call the fallback, and it worked. We can see our account balance went down, this went up, and the balance of the first account should be 1. Yep, it's 1. So now I want to show you events inside of Solidity. So what do we use events for? So events are a way for external consumers to kind of listen for things that happen on a smart contract. So basically, external consumers can subscribe to events on a smart contract and wait for something to happen. So what we'll do inside of this buy token function, we'll actually trigger an event that lets anyone connected to the blockchain really to know that a token has been purchased from the smart contract if they were to listen for it. So I'll create an event like this. Do it up here. We'll say event purchase. And I'll just say, I'll break this line right here. Oops. I'll say address, a buyer. And I'll say uint 256 amount. Okay. So that's how we declare an event, just like that. And inside of this function, whenever the token is purchased, we'll trigger it. And we trigger the event like this. We say emit purchase, and we pass in the buyer, and we pass in the amount. So the buyer in this case is msg.sender, the account that's calling this function. And the value in this case is just 1, semicolon. All right, so there you go. Now, another thing you can do with these events, you can create an index like this, indexed, okay? And that will allow you to filter events that are only from certain buyers. So basically, like, if you wanted to only listen to events from the smart contract that, a certain person did, a certain account, or maybe even just you could subscribe based on a specific address. So I'll show you how that works. All right. Let's compile this and run it. I'm going to take the wallet, paste it in here, deploy. All right. Now we'll call the buy tokens function. We'll send in 1 ether. Oops. All right, it worked. Now, how do we know the event worked? So we can look inside of this transaction here, see the log. And we can see right here, here's the log. And inside this log, we have some messages. And this basically is the event. We can see the buyer listed here and the amount. See the buyer was this address. And here's the amount. So what are events for really? There's 2 kind of main use cases for events. Because of the asynchronous nature of the blockchain, if you're building an application that if you're building an application that talks to the smart contract, you might call a function like buy token. Like if you're writing a JavaScript application, you might like call this function, and then your application would just know that you called this function, but you might want to actually wait for this to finish and execute, wait for this event to be emitted. So you can basically wait for that and subscribe to this event. And filter for only ones that are applicable to you. And whenever that happens, you can wait for that to happen, and then reload your application state whenever that event's been triggered. So that's one popular use case. Another use case is you can get the entire event stream from a smart contract like this. So you could basically see all of the purchase events because they're listed in these logs. They're actually listed in the transactions. That are contained in the blocks of the blockchain. And that's a way to see all the purchases that have ever happened inside a smart contract like this. So that's all I got for today, guys. I hope you all enjoyed this video. Be sure to subscribe to the channel if you haven't already, and check out the other videos in the Solidity playlist. And I'll probably be doing a lot more after this. So again, hope you all like that. Until next time, thanks for watching DAP University.